what I want to do here is just take some derivatives that involve the chain rule. We'll see why we call it the chain rule, and we'll see how complicated this can get when we start putting it in combinations with other things. Meanwhile, just a couple of examples, maybe 3 or 4. If I want to now take the derivative of, say, e to the minus x squared. By the way, e to the minus x squared is basically the bell curve. So you take derivative of it constantly. And what is this? Yes, I see e to the blob. The derivative of e to the blob should be e to the minus x squared times the derivative of the blob, which is just minus 2x. That just wasn't so bad. Let's make it a little bit harder. Call it example 2. This one actually shows up in studies of memory, which is kind of weird. I'm going to have e to the x. Well, my blob is this thing right here. So the derivative of e to the blob is e to the blob. This is my blob, and so I now want to multiply by the derivative of the blob, which is just e to the x. So that just wasn't so bad. Let's see why they call it the chain rule. If I want something like, how about sine of e, the cosine squared of x, like that. And I want the derivative. So we're taking the derivative of sine of e to the cosine squared x. Now I need to read this. Notice, by the way, when you use the chain rule, you start from the outside and work your way in, right? So what I see is sine of blob. The derivative of sine of blob is the cosine of blob. So I get e to the cosine squared x, like that. I think I'm going to try to use orange at each stage just to write down the blob, right? So the blob at the very beginning is that. Now, when I have to multiply by the derivative of the blob, what I see is e to the blob, right? So you notice, by the way, that the blob just got smaller. Meanwhile, I'm taking the derivative of this blob right here. That's going to be times, it's e to the blob. I'm still using the word blob, so I'm stuck. If this is now my blob, what I want to take the derivative of, how do I take the derivative of cosine squared x? Well, I could write that as cosine times cosine, but I want to use the chain rule. We have to remember that cosine squared x is actually just cosine of x quantity squared, right? So when I multiply by the derivative of cosine of x quantity squared, cosine of x quantity squared, let's see here. Just put this up here so I have it. This is what we actually mean by cosine squared x. And you can see that it's actually just blob squared. So the derivative of that blob squared is going to be 2 times blob. And you can see that my blob keeps getting smaller. I now need to multiply by the derivative of that. Now, when does this ever stop, right? When, in order to take the derivative of the blob, you don't need to use the word blob anymore. So for example, when I took the derivative of cosine squared x, I had to use the word blob because there was a blob on the inside. But when I get to this point right here and I see cosine x, we know the derivative of that is just plain old sine x. So I write, negative sine x. So I get plain old negative sine x like that, and we're all done. But this is actually an illustration of why they call it the chain rule, because you keep multiplying by derivatives and adding links to the chain. I think they probably could have come up with a better name, but it goes back hundreds of years and there we're stuck with it. So when you have a function inside a function inside a function, you keep having to multiply by the derivatives of smaller and smaller blobs. How about one complicated example before it gets too late? One complicated example. How if we try to take the derivative of something with a fraction and a chain rule like this. My gosh, we can make this pretty bad. Okay, how about here we put a 5 and then a cosine of, how about x, e to the x like that, and in the bottom we'll put the square root of x cubed plus 1. And hopefully we can fit this on here. Now, remember with derivatives, you don't start from the inside and work your way out. You're not trying to simplify, you're trying to take the derivative. What I see here is a giant fraction, and we know how to take the derivative of giant fractions. It's a big, huge, humongous fraction. I'm hoping I have enough room here. What do we have here? I know I'm supposed to have the derivative of the top, which is going to be really long. I'll try to give myself some vertical space here to put it times the bottom. Maybe, yes. Plus the derivative of the bottom times the top, all over the bottom squared. Bad thing about this is the bottom squared is not going to be so bad. Anyways, I'm going to put in all the stuff where I don't have to take a derivative first, right? For example, this says the derivative of the top, that's work. This is just the bottom, and so to prevent myself from screwing up, I'm going to make sure I actually put that in there. This is the derivative of the bottom, that's going to be work. What goes right here is just supposed to be the top. So I'm going to put 5 times cosine of x e to the x. It'd be nice to have a bigger whiteboard, but then it wouldn't fit on my camera. This is just the bottom squared. I'm just trying to put in everything so I don't forget anything. All right, here we go. Ready? What goes right here is the derivative of the top. Well, okay, what I see is 5. I'll pull the 5 out. And what I see is cosine of blob. The derivative of cosine of blob is minus sine of blob. So minus sine of blob times the derivative of the blob. Well, here's my blob. That's not a function inside a function, that's a product rule. So what's going to have to go right here is the derivative of that inside is going to have to be the derivative of the first times the second plus the derivative of the second times the first. Ta-da! Whew. All right. What needs to go right here is the derivative of the bottom. Well, that is square root blob. So what I'm going to do, I know the derivative of square root blob is 1 over 2 square root blob. That's one of the ones we worked for early in the semester. That's x cubed plus 1 inside there. Times the derivative of the blob. Well, the derivative of x cubed plus 1 is just 3x squared. And you can see how fast this stuff gets complicated. I'm going to have to try to find a better way of actually writing than just horizontally. Meanwhile, when you're working out these problems, this does give a lesson. Very frequently, I will have people turn the page sideways so they can fit the whole thing across. All right, enough examples there.